Of course, I want every single woman to make up her own mind. The role that I see myself playing is providing education, information, and the data so that every woman can think about what matters to her and weigh the evidence and make a decision, because no one that I know has a crystal ball to know for sure what will happen with any particular person. So if you look at what is we'll say the scientific background for the development of mammography, going back into the 1960s when the research was beginning, and then the 1970s when it was first begun to be implemented with what was then called film screen mammography, where they created a film that you could put up on one of those old-fashioned viewing devices with the light behind it, the light boxes and so on. And it's evolved over time. And then the question is, has it evolved in a way that has actually saved lives? Because ultimately that is the point. So if you just start by looking at the data in terms of mortality, and then we'll go back and look at why a mammogram even is like supposedly helpful. And so if you look at the data, for any one person, nobody knows what a mammogram will do, good or bad. So what I have to discuss is more population data, because every person could have a different outcome from anything. So if you look at population data, we're just talking about average women, and you look at the group that has mammography screening on a regular basis versus a group that doesn't get mammography, and you go out 30 years, what do you find? You find that mortality from all causes, and we call that all-cause mortality, that is looking at death from everything and anything, from heart attacks, strokes, from osteoporotic fractures, from different types of cancers, including, of course, breast cancer. The difference is zero. Statistically, there's no difference in mortality from 1,000 women. How many died from 1,000? It's the same. In fact, there was a slight trend towards more deaths in the groups that had mammography. Now, if you looked at breast cancer deaths, they were slightly lower, a little bit, not much. So what's going on here? And this is because the foundational premises upon what mammography was based on turned out to be wrong. And because of that, when you do mammography for any one person, it's like a coin toss, whether it's going to actually do any good or do actual harm. And that's because the foundational premise for a mammogram was based on a misunderstanding of breast cancer. Now, we're going back many decades, but things become entrenched. So I call it the breast cancer industrial complex, a multi-billion-dollar industry that's all built up around mammography. And that is like too big to fail. So now it will maybe transition, and I'm going to talk about some of the potential future imaging that may or may not be beneficial. But the foundational idea about breast cancer was that it would start out very small, and then it would get bigger and bigger, and it would hit some magical size, whatever that is, when it would metastasize. That means that cells would break off, travel through the lymphatics or the bloodstream to distant sites in the body, like the lungs, the brain, the liver, that type of thing, the bones. And there it would take off and grow, and ultimately that would kill a person. Women don't die from breast cancer in the breast itself. They die because of metastatic disease, that it spreads somewhere else, and that's what kills them. So the theory was breast cancer would start out little, grow, and then it would get to a certain magical size that no one's ever defined, and then it would just metastasize, and then your fate was sealed. Okay. And the idea was, if you find the breast cancer before it gets to that magical size when it metastasizes, you'll save a life. What a good plan. What a great idea, except it was wrong. Other than that part, it's perfect. So the problem is that breast cancer metastasis isn't based on size. It's based on certain cellular characteristics that deal with cohesiveness of the cells of the cancer. So if they're like stuck like super glue together, then that cancer can be invasive locally in the breast and get bigger and bigger and bigger and bigger. But because the cells are like stuck together like super glue, they don't break off and travel to distant sites to create ultimately death. But you can have a very tiny breast cancer that is not like super glued together, and little bits of it metastasize when it's really tiny and then spreads throughout the body. And this is a characteristic that's inherent to each cancer itself. And there are certain things that we can talk about, but right now, this is one of the big issues involving investigative and research, because this is recognized in this oncology cancer community. And there are people working on this problem so that if you had a breast biopsy, and at least at that stage, you would say, this is a breast cancer that is the kind that spreads, or not the kind, or it might spread, but wait until it's really giant. Then you would know how to treat the cancer. So that's one problem. So because of this inherent problem of breast cancer can spread very early, or it can be very big and never spread, finding it early doesn't mean you saved somebody's life. So if you do a mammography and you find a breast cancer, in most cases, that woman's fate is already sealed, whether it's that it's never going to kill, or it already metastasized, even when it's quite small. That's the problem, is that finding a breast cancer just means, oh, found it. It doesn't mean that person has now been saved. Sometimes you do save somebody. Sometimes you will find a breast cancer that was destined to metastasize in the next year or two, but you actually found it before that happened. That happens sometimes, but that's a minority of cases. But it's not a 0%, it's a small percent. So how do I know, or anybody know, if any particular woman walking around in her 40s, 50s, 60s, 70s may be that one who actually could have her life saved? We don't know. But what about all the other women? Well, since finding it isn't going to change anything, what about the harms? For one thing, what if you find a breast cancer that was never going to kill the person, ever? But I'm not talking that it's not breast cancer. It is breast cancer, but it would never kill. Well, that woman now is going to not be allowed to be on hormones, which can change everything for her future, because hormones are foundational for health. But without hormones, nothing can work right. Okay. Next, take the hormones away from those women. Then they give them drugs that will block the production of estrogen through the conversion of androgens in their brain, in their gut, in all these different organs. So now they have not only, there's no ovarian production if they're premenopausal, but if they're postmenopausal, they don't have any conversion, because that's one of the ways that women can have some estrogen after menopause, is by converting androgens, most of which come from the adrenal gland, into estrogens in other tissues. We call that paracrine. It's made in that organ. It's not circulating. So we don't have that ability if you block the enzyme that makes the conversion. That's what aromatase inhibitors do. Okay, like anastrozole, Arimidex, those drugs, Femara, they block, and it's like letrozole, they block this enzyme. So that leads to all kinds of problems. And then, of course, there's surgery, there's radiation. Radiation to the breast is radiation to the heart, even when it's on the right side. They've now shown it harms the heart a lot. And it also is to the lungs, increasing not only heart disease, heart failure, heart attacks, but also potentially lung cancer. And just a lot of scarring, discomfort, and so on can ensue from that sort of thing. And then there's the emotional trauma. Women who go through this 100%, really 100%, get post-traumatic stress disorder, and emotions change everything. Chronic stress and post-traumatic stress disorder is not conducive to healthy longevity. So we have all of that. And this is from women who have definitely been diagnosed with breast cancer, but it turns out that that wouldn't actually have killed them. But we don't know that's the problem. And what percentage is that? Probably at least 30% of all breast cancers that are found were never going to kill. And what do we call that? That's called overdiagnosis. It's not false diagnosis. It's not any kind of a fake or a mistake. It's just cancers that were never going to kill because they have certain characteristics, like I said, that they were not going to metastasize, or they may be growing so slowly that they would never do anything. Some cancers actually stop growing and some even disappear. I mean, every cancer doesn't kill, as you may think that. They did a study with lung cancers doing CAT scans, and they found that they would discover twice as many lung cancers as ever killed anybody or had treatment. So there's like apparently a 2-to-1 of potential for overdiagnosis of lung cancer. And they've had other cancers that have been studied where they do screenings and find way more cancers than ever actually kill anyone, because they're finding the cancers that were never going to kill anyone.